What would happen if we gathered all the largest moons of the solar system in one place and made them collide? And do it all in Earth's orbit. Today I'll test this in the Universe Sandbox simulator and find out what kind of planet we'll get in the end. Let's go. And the first to collide with Ganymede, as we can see, will be Uranus's moon Oberon. Oberon is the second largest moon of Uranus, and it's having a grazing collision with Ganymede. Let's see what kind of impact it will have on Ganymede. This is only the first moon. And as we can see, it melted Ganymede a bit, and liquid reservoirs are appearing on it. Some fragments have appeared here. In short, this is the effect of the first collision. Meanwhile, in the simulator, 2 minutes are passing per second. And here, besides the moons of Uranus, there are moons of Neptune, Saturn, and Jupiter. And there's also the moon, Earth's satellite, and there are moons of some dwarf planets. These are Namaka and Hiiaka, moons of Haumea. Dysnomia and Charon are the moons of Eris and Pluto respectively. Here we see Triton has already collided. And another moon. Here Steth is flying in for a collision. Not far away are Callisto and Enceladus, as we can see. Fragments have already flown out. I hope they don't block our view. And here comes Europa and Enceladus and Callisto almost simultaneously. And Titan is flying in from above. Wow. This is going to be insane. Oh my goodness. Callisto and Titan are colliding at the same time. Ganymede is growing. Whoa. Dione and Umbriel are also about to collide. Everything is blinding. I can't see. Anyway, I need to hide this dust and gas here so you can see everything in more detail. Okay, the moon is moving in for a collision. The moon is already red hot here. Oh, and Ganymede, as you can see, has already been flattened. Most likely these impacts have spun it up around its axis. Look at its appearance. Oh my, this is really insane. Okay, I see Mimas, Hiiaka and Namaka flying in. Well, these small moons won't cause much damage. Well, of course, one of the largest moons is still left, Io, a moon of Jupiter. I'll speed up time. And it's flying a bit higher. Maybe it will even out the day on Ganymede now. That would be nice. Okay, it's grazing Ganymede. And oh my, look at this merger. Well, Io is enormous. I hope it doesn't destroy Ganymede now. No, Ganymede is actually losing this fight. Well, for now it has survived. But here's Io. Look what's happening to Io. It has also stretched out and it's actually eating this Ganymede. Wow. No, Ganymede is holding on. Okay, I'll speed up time. So what will be the outcome? Who will win? Oh my goodness, no, Ganymede actually won. You saw that. With its last bit of strength, Ganymede defeated Io. Incredible. But it seems to have spun it up even more. Wow, it really got squashed. I'll turn on the gas display. Oh, and you can't see anything at all here. Everything is blinding, just like this. I'll speed up time again. Let all these gases disperse and the view will be better. This process is so beautiful. Look at how many fragments are flying out. I don't know what the mass of that object will be, but we'll see now. In the end, we got this object. It's Ganymede, but its mass is only 2.46 times the mass of the moon, and its radius is about a third of Earth's. And the temperature here is dropping. And just look at the shape of Ganymede, how elongated it is. Because its day is 2.5 hours long, a very fast rotation on its axis. Well, the collisions were at high speeds, and apparently this is what happened. So I decided to redo all this and collided all these moons at a very low speed with Ganymede. I'm starting the simulation, 1 minute passes per second. Look, here's the mass mark, the radius mark, how it will all change here. Meanwhile, the objects are already approaching, and the first to collide, as is tradition, is Oberon. Now everything else will collide after it. As we can see, the mass is growing, the radius is growing, and of course the temperature is rising. And as we can see, Ganymede is also growing before our very eyes. Everything is very fast, and this time it seems to be working out. Titan entered. Now Io is colliding with Ganymede. The mass is nearly 8 lunar masses. I'll hide the gases. This way everything will be more visible. Ganymede has collided. That's it. All the moons have calmly collided with Ganymede. I'll turn on the display of these gas-emitting elements again. And I'll speed up time. Let's see what happens next with the mass and radius. Well, some particles flew out after the collision. And they will fall back. Ganymede has already formed more than 8 lunar masses. I'm speeding up time. And here the mass is still adjusting a little. But overall, I think it has already stabilized. Now 1 month passes per second. This planet is already cooling down. In the end, we see that the mass has formed at 8.32 of the moon's mass and the radius is 0.65 of the Earth's radius. It's safe to say that this planet is larger than the planet Mars. If you look at the external shape of Ganymede, it's not as flattened as in the first part of the experiment. The solar day is better here, but it's still not very good, 6.5 hours. And now we need to wait for the planet to cool down and see what happens to it in the end. That's it, the temperature has stabilized at 171 degrees Celsius. A very hot planet has formed. I'll hide the atmosphere and clouds. Here we see such a surface, it looks like there's still ice left. And in the places where the collisions occurred, you can clearly see craters of different sizes. And there are also large craters from collisions with larger moons. But the atmosphere is quite dense. If you look at the atmosphere, you can see that there is a lot of water vapor, 658 times that of Earth's atmosphere. There is a lot of nitrogen, 10 times Earth's atmosphere. There is also a lot of carbon dioxide, more than 2 of Earth's atmospheres. I knew there would be a lot of water here, because many moons in the solar system have a lot of water in their composition, as well as in their mantle. The pressure on such a planet is almost 70 atmospheres. The greenhouse effect is 188 degrees Celsius, and so basically this is the kind of planet that has formed. But it's like this in Earth's orbit. Let's try to check what it will be like in Mars' orbit. Maybe it will cool down and become better. As you can see, Ganymede is here in Earth's orbit. Now I'm moving it to Mars's orbit, and I'll set its orbital period to 687 days. Here I've also displayed the orbits, and you can see that Ganymede is in Mars's orbit. I've started time, it's running at 1 month per second. Now look at the temperature, and you'll see that the temperature is starting to drop. And that's it. The temperature has stabilized at 84 degrees Celsius. It hasn't gotten particularly cold here on Ganymede, but the dense atmosphere is to blame. If we hide the atmosphere in clouds, we can see that more of the ice has simply melted, and that's it. You could say, to put it mildly, that an ocean planet with a dense water atmosphere has formed here. And we can see this non-standard rotation of the planet because its axial tilt is 102 degrees. So this is basically the kind of planet we got. Now let's move on to the next part of the experiment. And now I'll try to make something normal out of this planet. We'll leave it in Mars's orbit. And the first thing I'll do is give this planet a normal day length. I'll set the day value to 1.5 days. Oh, look how Ganymede has recovered. It already looks better. If we look at the surface in this case, not much has changed here. And the axial tilt can be adjusted to make it much more reasonable. Let's make it at least 32 degrees. And we see a lot of water in the atmosphere's composition. But all this water is present in large quantities in the mantle, and there's also quite a bit in the core itself, as it shows. Well, for starters, we can try to zero out the water from the atmosphere's composition. I'll just go ahead and set it to 0. It appeared right away, but not enough. The atmosphere is still not transparent. Let's try 0 again. 123 Earth atmospheres. And I'll try to zero it out again. Well, it's decreasing. Oh, and if I do this, the planet actually shrinks in size. Yeah, apparently I started taking water from the mantle. Yeah, that's right, and there's less water here now. Well, it means I'll have to make such sacrifices that our planet will become smaller. But I want it to look at least a little more attractive. Oh, no matter how much I decrease it, the water just keeps going into the atmosphere, on and on. This is crazy. Okay, it seems I've managed to remove it from the atmosphere. I'll take a look at the surface. This is the situation here at the moment. Well, it seems to look a bit better. And some islands have already appeared on the surface of Ganymede, and they are here and here. But I want to try to give Ganymede a normal atmosphere so that it's more transparent. For example, sulfur dioxide. I'll reduce its amount by 10 times. And also carbon dioxide. Well, it's mostly nitrogen here. If I reduce the nitrogen by 10 times, oh, now that's a different story. But I'll still try to melt this ice on Ganymede. Let's see what happens. Oh, the islands weren't flooded, that's good. And now the planet is completely covered with water. The sea level is 6 kilometers. I'll try to decrease this value. Okay, well, let's make an archipelago of islands like this. Let's at least have it like this, it's already better. And the pressure is kind of low, but it's rising. And look at this situation. We have vegetation appearing on the surface, and the pressure, by the way, is normal. A little over 1 atmosphere. Now it's dropping, but I hope it won't drop too much. 1 month is passing per second, and it seems I've managed to make something more interesting. But the temperature, as I can see, is rapidly dropping. Yes, the temperature is indeed dropping significantly. In Mars's orbit, it will be very cold here, and as we can see, life is starting to disappear. So I'll move Ganymede back to Earth's orbit and set the orbital period to 1 year. I'm starting the simulation again, and as I can see, the temperature has reversed and now it's starting to get warmer on Ganymede. Some time has passed, and in the end, the temperature on the planet is over 47 degrees Celsius. On the surface, not all islands are green, but for the most part, as we see, all the islands here are green. Closer to the poles, conditions are much better. Otherwise, the planet has become a bit hot. I'm turning on the display for atmosphere and clouds, and the planet looks like this. Remember I said that the size was decreasing when I removed Ganymede's water, and in the end its mass became 4.69 of the moon's mass. And the radius, by the way, also became smaller. If you compare this planet to Mars, you can see that Mars is now larger in size than this Ganymede. If we take Mercury, everything is about the same. Surface pressure is just over 1 atmosphere. Life likelihood is 27%. And apparently there are lights of night cities on Ganymede. Look at these glowing spots deep in the night. And what if we also try to add rings to the planet? For example, these rich, much more interesting ones. And also add 5 moons to Ganymede. And I've set these orbits for these moons. And if you look closer, they are in the same plane as the rings and the planet's axial tilt. It looks absolutely perfect. And you have to agree, now there's something to look at. So, this is the kind of planet that was made from one of the largest moons of the solar system. Write in the comments if you expected this result, and don't forget to also like this video. Thank you very much.